Welcome back. This is part 5 in the videos on pointers. Last time we looked at the relationship between pointers and arrays. In summary, we saw that an array name is the same as a pointer, and arrays can be accessed as if they were pointers or as if you were using subscripting. We turn our attention to user-defined data types that you get from struct and classes, and we see that they are data types like ints and floats. Therefore, you can create pointers to variables of those types. Moreover, you can dynamically allocate variables that are defined by classes and structs, and we're going to look into that. We will finish with some examples, some programming examples. So, if we have a struct or a class, we can always define a pointer to it, because the rule is data type followed by a star creates a pointer. So that if we have a student, which is a student record, student 1, then we can create a pointer, a student pointer, and initialize it to the address of student 1, and so on. Okay? Now, the important thing is if I have a struct, a pointer to a record, how do I access a field? The important thing to note is that the expression in parentheses in red is the dereferencing. If we dereference a pointer to a student record, it places us at the beginning of the record, at which point we can now do the field selection. So here's a side note. If you look at the different operators that you see, you have a field selection operator, you have a dereferencing operator, and the rule is dereferencing has lower precedence than field selection. So we must put this in parentheses to force the pointing to the beginning of the record. Right. All right. There's an alternate form that is preferred, and that is to use dash greater than. Just call it an arrow. Certainly it's more visually indicative of using pointers. It has the same meaning as using the dereferencing in parentheses followed by field selection. It has the very same meaning, but I hope you see that it's a little easier to write and there's fewer things to get confused about. Any data type can be used in dynamic allocation, so I can get a new student record and point to it. Reminder, what does new do? It creates space, it requests space from the operating system based on the data type, and it returns the address of that new space that was acquired. Similarly, you can delete a dynamically allocated variable with the delete instruction. Now here's the last thing we want to look at before turning to the programming examples. It is possible that a field of a record can itself be a pointer. So with grade lists, we have a course number and a pointer to some grades. Now, how do we access the grades field, remembering that it is a pointer? All right. So first of all, let's declare a grade list called test1 and a pointer to a grade list, and we're going to have that pointer point to the record test1. This table tells us different interpretations. Test1 pointer accesses a record. The pointer says access the record and select the grades field. That's one way. And this again is the same as saying dereference the pointer, then select the field. What does this mean? Well, we have two interpretations. This can mean do this first, or it can mean do this first and then dereference. I said earlier that dereferencing has lower precedence. So the compiler will interpret this to say, let's do this first. And what does this do? This accesses the grades field. What's the grades field? Whoops, the grades field is a pointer. So we have a pointer. Since we have a pointer, we can dereference it. Dereferencing it will access the integer value that's pointed to by this field. All right, what's the last thing here? Test1.grades. Again, dereferencing occurs last. What's test1? Test1 is our variable, no pointer. This is our record name. So test1.grades is the grades field. But what is the grades field? The grade field is a pointer, therefore it can be dereferenced. All right. What's the bottom line? The dereferencing operator has lower precedence. So when you see an expression, just be reminded that the dereferencing occurs last. Now let's turn our attention to some examples. So we will go through a series of small programs, transforming them from a program that does not use pointers to one that does. So what we got here? Let's do struct 0. Let's take a look at it. And what we have is a car, and the car has 4 fields, and it's a struct, so we can provide constructors. Notice that we have 2 constructors. We have a default constructor that sets the color to clear, the price to 0, the make to no name, and the year to 1900. And we have a non-default constructor that we can set of the year, the color, the make, and the price. Right. And so let's see what we're doing. We want to create one car, and it's going to be a 2015 orange Lexus that costs $45,000. And we're going to create a second car that is not initial, that will be initialized by the constructor. And all we want to do is display the attributes or the member data for the 2 cars. All right, let me enlarge this a little. So we can run it. I think this is called S0. All right. For car 2, I want it to be a blue 1969 This is my first car, okay? And so that we see the program without pointers is able to get information for 2 cars and display that information. Now, let's transform this program. Now let's look at the first version of our transformation, struct A. Notice that it looks the same, except that we're going to introduce one pointer to a car, CP1, and we're going to replace the way that we handle car 1, this time using a pointer. So in the old version, we took car 1 and we declared a variable directly, and we used the non-default constructor to initialize it. We're going to do the same thing here. This time we must use dynamic allocation. So we're going to say create a new car. make it a 2015 orange Lexus, and let's save the pointer to it as CP1. We will initialize car 2 the same way we did before. Now let's take a look at what we're doing. In the past, we just directly accessed the fields of the C1 record, and now we must access those same fields, but this time we must do so using a pointer. So how do we access a field of a record if we have a pointer to the record? It is the pointer name, arrow, field name. So if you look carefully, we're just substituting what we had before. Instead of saying C1 color, we're going to say we must point to the color through pointer CP1, and so on. All right. Car 2 we left the same. So we should be able to run this. I think it's called SPA. Let's see what happens when we run it. Now car 1, again, we are accessing it through a pointer, so we're just going to say this is a red 1974 Beetle, which I never had, for $600. Alright, so we have the same program. One of the variables is initialized without pointers, is created without pointers, and it's a static variable, not a dynamic variable. It's not static either, but so that's one way. The other way is we're going to make both of these cars dynamic. To do that, we require 2 pointers. Creating the pointers does not create the car. You must allocate the car using the new statement. We're going to allocate one using the non-default constructor, where we're able to supply the vital information. The second one, we're going to use the default constructor. Why is this the default constructor? Because we do not pass parameters. We just say, do whatever you normally do, which means the default constructor is going to be used to initialize it. And notice that now we have changed the car 2, where it used to say we read directly into the fields, but now we must access the fields through the pointer. And the pointer for the second car is CP2. So to access any of the fields is just CP2 point field name. And when we run this, we'll see that it does pretty much the same as before. By the way, examples of this code are found in the public repository. So this is a yellow 2000 and Kia for $12,000. Alright. Now we're on a roll, so we'll just finish off by switching this to a class. Now we're going to look at a class. Let's take a quick purview of this. We have a class. It has public members. One is a variable called color. It's public. We have a private variable called cost. We have 2 constructors. Which one is the default constructor? This one. It has the same name as the class, but it does not take parameters. And what's the purpose of the constructor? To initialize. So we're going to initialize the class variables to clear for the color and cost 0. All right. So we have 2 of these. We have 2 objects, T1 and T2. T1 is defined using the default, and T2 is initialized using the constructor. And we're just displaying the color. Notice that the color can be accessed using field selection because color is in the public section. Whereas cost can only be accessed, yes, through a function call. What function call? Show cost. What does show cost do, by the way? Show cost does not return the cost, it just displays the cost. So let's run this. C0. And that's that. What do you think we're going to do now? We're going to take this, and as we did with the struct, we're going to replace one of the variables we had before with dynamic. So T1 is not going to be a dynamic object. So we create the pointer T1. It can point to a T1 object. We're allocating it using the default constructor. We are creating a second object T2, and we're going to initialize it using the non-default constructor. And now we're going to display the color of T1, but this time what's the difference? T1 is accessed only through the pointer PT1, so I must access it that way. And when I do this and run it, we see that T1 is okay. It worked the same way as it did before. We can locate that. Same as here. So switching over to a dynamic variable doesn't affect anything. And the final thing I want to show you is what happens when we make both of the objects dynamic. We need two pointers. Notice that in the declaration I must put the star twice. If I don't put the star, it means I just want an object. I don't want a pointer to it. So if I want two pointers, I got to say star and name, star and name. All right. If you look at this carefully, what is the difference? The difference here is that I really must call the show cost function. And I must use the pointer to access the color for T2. So if you look at this carefully and run it again, you get the same outcome. So therefore, we've shown you basically the basics of using pointers to structs and pointers to classes.